Hey folks, here to talk about small block Chevys and Vortex and pocket porting. Just going to share some stuff I found out. Looking around on YouTube, haven't found a whole lot of super useful stuff on here, so I thought I'd do a little tutorial of what I've been doing and what I'm looking at, see if it can help somebody else out. So this all began, I got my 70 Camaro here, and I was checking out the engine. The guy I bought it from, he didn't know much about it. He said he had it rebuilt. I ran the numbers, and it's an old truck engine from the mid-70s. The heads that are on it are nothing special. Pretty big combustion chamber, I think like 76 or 78 cc's. Not really a performance head. Probably has an RV cam in it. Sounds okay and it pulls all right, but I wanted a bit more. So I started doing some research and found out the Vortec heads are a really good budget upgrade. And since I'm working with a budget, that was just for me. So the two casting numbers that I found out are good for the Vortec heads are the 062 there, and then the other one is 906. I found these heads in a junkyard. I picked up the pair for 120 bucks, and that had all the Valvetrain and valve covers and everything. You can find these on 96 through, I believe, 2001 GM trucks, SUVs, and vans. I looked through about a dozen different vehicles. These looked really good. I haven't cleaned these at all, so that's how they were when they came out. So the other thing is I have found some info. I'm not sure if it's right or not. I find conflicting things. The 906 supposedly has a slightly different valve seats, and that supposedly reduces some flow at low lift. I found some other articles that said that's not true. They're pretty much the same. There are other 305 Vortec heads and a few other casting numbers. I don't know what they are, but all that I do know right now is the 062 and the 906 came off of the 5.7, and those are the heads you want. My engine is a 350 that I'll be putting this on. And a couple things as far as specs that I'm aware of on these heads. They're 62 or 64 cc chambers. The intake valve is 194, and I believe the exhaust is either 050 or 060. Sorry, 50 or 60. And I think that the intake runners are 170 cc. I don't know flow numbers like CFMs or anything right now, but arguably this is the best production head that you can find. Obviously, aftermarket stuff, you can get bigger valves, bigger runners, but if you're working on a budget, this is a good option. And like I said, I picked these up for 120 bucks. I went in and pulled them myself. It took me a couple hours because the engine was complete, so I had to undo all the accessories and everything. So, a couple things that you have to look at doing when you get these Vortec heads. One of the limiting factors is the amount of lift that the Valvetrain can take in stock form. I should have left this down. So, your seats and your guide bosses here, they're in the geometry with the rocker arm here. They can only handle about 430 to 450 cam lift before you start getting bind against your seal here. So you either got to look at cutting the seat and the boss down, and you can either have a machine shop do that, or there's some tools you can get that attach to a drill that you can do it yourself. Also, these are press-in studs. A lot of folks prefer to switch over to the screw-in type. Again, there are tools you can do to do this yourself or take it to a machine shop. And depending on how much you cut, that's how much additional lift you're going to get. So you can get anywhere from 500 to 550 lift. I don't know the limitation, so I'm not going to try and tell you something. There is another option that I found where you can get beehive style springs. I know Comp Cams makes a set for this, And I've read on forums that there are guys that are taking the LS6 valve springs and putting them in here with a Comp Cam's retainer kit, I believe. I don't know all the specs on that, so you can Google it and look it up yourself. The other option that I found, and this is the one I'm going to go with, is there's a gentleman named Russell that has a company called Diabolical Racing, and he makes a beehive style spring specifically for these Vortec heads. Unmodified, you can slap those new springs in, and they come with retainers and clips, and he claims you can run 530 lift. He has his own engine with Vortec heads with his own springs that he's been running, and he's had great results. Go check out his website, read his stuff. I was convinced to give it a shot. Also, just speaking with Russell, very knowledgeable. He answered all my questions, very polite and professional, and I believe he has a quality product. I'm looking forward to trying it out. So those are the things you got to look at when getting these Vortec heads, either the machining or you get different springs. The other thing you got to look at is there's a couple differences. The valve covers themselves, if you don't get valve covers, take the factory ones from the junkyard, they are the center bolt style. So you can't just use the old small block ones that have the bolt holes on the outside here. The other thing is the intake manifold. The bolt pattern is specific to these style heads. It's not the same as the 55 through 86 small blocks. It's a straight down, or at least on the manifold itself, it's a straight down rather than in at an angle like the older school stuff. So that's something to note when you're getting an intake manifold. You have to get the Vortex specific one. I know that I believe it's a Speedmaster, Summit makes one, Jegs makes one, Wayend, Edelbrock. You can find them. They're usually just a little bit more expensive than your standard intake manifold. The one I'm going to be running, it's a Summit brand, dual plane. It's either a mid-rise or a high-rise, and it's about $200. So those are the main things you got to be aware of. And you can run these stock as is, so long as you keep a cam below that 430 lift. You do the modifications, obviously that's going to be more. And if that's all you do, you can have a good running engine, definitely making 350, maybe even up to 375 horse, depending on the rest of your application. One of the things that I found in my research while I was discovering the good and the bad of these and what you have to do to make them run, there's an article, I think it was by Hot Rod, and they did what's called pocket porting. And according to them, excuse me, by doing just the pocket porting, and I'll explain what that is here, they experienced a 20 horsepower increase. And they did flow bench testing and they did dyno testing, so this isn't just rhetoric. And you can Google it. I see if I can post the link with this video. But so what pocket porting is, if you look in here, you can see where the casting meets the machining. That is the pocket or the bowl. And if you run your finger in there, you can actually feel a ledge, if you will. And all that pocket porting is you take that transition and you take it from a sharp edge and you blend it into a smooth curve. And that's what I've done over here on this set. I've gotten rid of that sharp edge and I've just sort of rolled it over. I didn't take out a ton of material. And then when you run your finger across it, it's just a nice smooth curve. You don't feel any sharpness. And I did that on both the exhaust and intake side. One of the interesting things in the article, the dyno guy that was running it, he suspected that there was a greater benefit on the exhaust side than the intake side. And that seems to be the agreed upon theory that the exhaust is the quote-unquote weak point of these heads as far as flow. So the work you do on the exhaust side is where you're going to experience most of your gains. But since I'm doing it, I decided to just do the whole thing. The other thing to note, when you're looking in here at the valve guide bosses, there's a big machine surface there, big flat surface. They recommended sort of blending that as well. And granted, mine is not pretty. I'm a novice. I'm not an expert at this at all. The whole purpose of me is doing this video is I didn't find anything on Facebook about this sort of work, and I figured I'm going to try this out, and I thought maybe I can help somebody else out in the future that's looking to do the same thing, or maybe they haven't looked at this and maybe they'll go, I could do that. So I'll probably clean that up a little bit more. You can probably see it a little bit better that way. But all you're doing with all this stuff is you're just sort of reshaping the sharp edges. You're not looking to take a ton of material off. You're not looking to do a full port. Part of the reason I opted not to do that is I am not an experienced machinist, and I don't want to screw up my runners by making a mistake and either cutting through the water jacket or changing the shape of these runners. Because from everything I've read, the key reasons that these heads are so good is both the combustion chamber shape and the intake runner shape. While having a relatively small valve, these are 194s, and a relatively small runner, I think they're 170-ish. Don't quote me on that, but I thought that I read that somewhere. These flow really good, and part of the reason is the velocity is good through these heads. You'll get a lot of guys out there that you want to do a full port. Well, yes, that's good if you've got either a large displacement engine or a high revving engine. You need to be able to flow a lot of air. My engine, it's probably going to quit making power around 5,500 or 6,000. So for me, in this application, this is what's going to work best at this point, and also my budget. That's all that's going to allow. So the article that I read, it specified just blending that edge in there and also not going super deep. I think they said about a half an inch. And then rolling those edges over on the guide boss. Another thing that you'll note that I did here is I tried to clean up my combustion chambers. And part of the reason for that is with the factory casting, as you can probably see on this side, there's a lot of carbon buildup on here. And part of the reason for that is the texture on the combustion chamber. You can see some of the exposed casting there is sort of, not sandpaper because it's not that rough, but you can definitely feel it when you run your fingers over it. It's not exactly smooth. Well, what happens is you get pieces of carbon that catch in those little voids and build up, and you get what you see here. And in a high performance engine, when you have carbon buildup, those become hot spots, and those hot spots can detonate. And if you're running performance, you know that detonation is bad. You want to be able to control that spark and that flame propagation. So that's part of the reason that I decided to clean these up. Again, not pretty. I'm not claiming to be an expert. This is just a novice that read an article and is trying to have a little bit of fun and learn something on the way. I'm sure there's people out there that have done this and they've probably done a lot better job than I have, but they didn't post a video, at least not one that I found. So my goal with this engine is about 400 horsepower. Or sorry, let me back up. So what I use is this Dremel tool here. And I just went to Harbor Freight and I got an accessory kit. Has a whole bunch of sanding wheels, grinding wheels, yada yada. I mostly use the drums. They seem to work pretty well. The stones, they work well too, but they wear down really fast. I mean, this guy right here, he's practically done. Nothing left to it. But I'm sure there's other stuff you could find. Yes, I could have gone and got carbide bits, but I purposely went with the Dremel instead of an actual grinder, and the sanding wheels instead of carbide because, like I said before, I'm a novice. So I wanted to make this easier for myself and even if it took me a little bit longer, I didn't want to screw things up. I tried to stay away from the valve seats, as you can see there. I will be doing a hand lap with the valves later, but it was important to me to not damage this and to make it better than what it is. So that's why I used the Dremel and the sanding wheels. It's not super pretty, but I'm hoping it's an improvement on what it was stock. So one thing to note here, Russell from Diabolical, I was speaking to him about these Vortecs and his springs and everything. He built an engine for a customer that he didn't do any of this work with the heads. Granted, he does head work, and I'm sure he does a far better job than I do, but he left them stock. All he did was clean them up. And he just put in his spring kit and an aftermarket cam. I don't remember the specs on it exactly. I want to say it was around 230, maybe 236 duration, and might have had 500 lift. But what they ran in a 355 with what I mentioned earlier, he said they got 410 horse and 410 torque. So I'm hoping that I can repeat those numbers, particularly with the modifications that I've done here. And again, Russell's super helpful. We emailed a lot back and forth. He didn't hesitate to answer my questions. I felt like he really knew what he was talking about. Didn't seem like he was blowing smoke up my skirt. So that's that. And just to show you here, I saved all my valves, and yes, I kept them in order so I can match them back to their appropriate place. This is one of the exhaust valves. It doesn't look perfect, but I think I can get most of that back out with valve lapping. And I'll work on that. I haven't cleaned these. This is just how it came out, which I don't feel is really that bad. The intake side is better. I mean, almost all of the intake valves look like this. I haven't cleaned that again. And that seat looks pretty good to me. I'll still lap it. Not a lot of carbon buildup. So, but yeah, I just wanted to share with everyone what I'm doing here in case somebody's looking at trying this themselves. I will be making more videos as I finish my work here and put them back together and ultimately put them on the engine. If anybody's curious, the cam I'll be running, it's a Howard's cam. There's the part number. It's essentially a 3030 Duntov replica. That's the cam that came in the old Z28 Camaros. 264 duration at 50 thousandths, and that's both sides, and 485 thousandths lift on both sides with 112 lobe separation angle. And it's a mechanical flat tappet. One thing, if I were to do this over again, so Howard's actually makes a lifter set. They have, this package isn't open yet. So on your lifter face, you can see these are just flat. That's a standard flat tappet. So one of the things that Howard's, and there was a couple other companies they did, they took a laser and drilled, I want to say it's like a 20 thousandths hole right in the middle of the lifter face there. And they call it a direct lubrication system, which is awesome because, as you know, these get pressurized and then the oil travels up your push rod to the top of your cylinder head. Well, somebody got wise and said, well, let's let some oil go straight onto the cam lobe. I got this a while ago and I wasn't aware of that. So if I were to do it again, if I were going to do a flat tappet, I'd probably get that direct lubrication lifter set, particularly with a flat tappet. Another interesting side note, on the motors that have these Vortec heads, they're factory rollers. I picked up the set of heads for 120 bucks. When I was talking to the guy at the front counter, I just asked him how much for the whole motor because I noticed that it was a factory roller system. He said 230 bucks. I should have just pulled the whole stinking motor, but here I am. This is what I'm going to be working with. And like I said, just to recap, Vortec cylinder heads, you want the 062s or the 906s. Either look at cutting down the guide boss and the valve seat, or getting the beehive springs. I wish I had them here with me. And then you got to look at the different intake manifold, and you're good to go. And if you want to be adventurous, you can be like me and get yourself some tools and start looking at the pocket port. And like I said before, when Hot Rod tested, they got a 20 horse increase just from the pocket port. So I'm hoping I see that as well. I'm trying to think if there's anything I missed here. I don't know if I said this, but I didn't want to try a full port because I didn't want to cut into the water jacket. I didn't want to screw up the shape of the runner. And for the cam, I'm running with the displacement of my engine and how I'm looking to drive it. I didn't see a huge advantage in trying to fully port this thing. And also, I didn't want to just screw up the heads. I figured since I'm new at this, I'm just learning. I'll baby step. I'll put my toes in the water and I'll just try this. This seemed like a relatively low risk operation to do. And so far, I don't think I've caused any damage. We'll see. But well, folks, hope this was helpful. If you have any questions, post them down in the comments. Again, small block Vortec, just doing a little upgrades. Hope you all enjoyed it. Have a good one.